Alright, so here we go, 2010, 2011 individual rounds, comp 2. Alright, here we go. Supposing a shipping container has a length of 1,000 meters and a width of 136 feet. I'm drawing the container. There we go. Okay, so 1,000, and then width of, and 4 containers. All right, stacked on another on a ship. How many 20-foot long containers can fit on a ship if the containers are 8.5 feet wide and 8.5 feet high? Well, it says they can go 4 containers high, so I'm not going to worry too much about that. So here's the thing. Oh my goodness. Alright, so we have 1,000 divided by 20 equals 50. Oh, so that's convenient that it goes in perfectly, right? So you can get 50 on that side, and then 136 divided by 8.5, so you get 16 this way. So is it as simple as just multiplying 16 times 50 times 4 to get 3,200? It is that simple. I remember a problem like this on math counts where it didn't go in evenly and you had to sort of configure things. So you maybe had some like this, but then you had to have some long ones too going the other way. So be careful on that, but I don't think we'll see that in mathletics. Math counts definitely. Find the smallest positive integer that results in a palindrome when divided by 2, 3, 4, and 6. Find the smallest positive integer, smallest possible integer that results in a palindrome when divided by 2. Alright. That's an interesting problem. So how would you go about doing that one? So the answer is not a palindrome. So we're looking for a multiple of these. And so the multiple has to go into all 3 of these, or all 4 of these have to go into it, right? So what goes, so 2, 3, 4, and 6. So what goes into all of them? Well, it's the sum of them. So we have 2, right? So it's 1, 3, 2, and 3, and then you have a 3. So then you have 1, 1, 2, 1. So the greatest common multiple here is going to be 12. Right? Okay, so the question is, what multiples of 12 are palindromes, right? So, not a palindrome. No. 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 I'm having troubles here. It's not working. So I'm not finding it. So my first thought is not going to work. So the smallest positive integer that results in a palindrome when divided by. Okay, so what palindromes are there? That's the other way to look at it. So we have small ones. So we have 33, 44, 55, 66, 77, 88, 99. So it's probably not going to be much bigger than that. So the question is, results in a palindrome when divided by 2.
The piece that lives in his body. But the 6 Horcruxes then, said Harry, a little desperately. How are we supposed to find them? You are forgetting. You have already.
So you know what I would do on this one? What I would do is I would take the calculator. I'd probably make a linear expression out of this that has 66. So what I'd probably do is I would do y1 equals 2x plus 66, y2 equals 3x plus, that's going to be a pain in the butt to do, because then you have to try all of these. So, yikes. So you can always try the guess and check method. Yikes, this is not going as well as I would hoped. So I'm guessing it's 66, because it's somewhere in the middle, right? 66 times 2 times 2. Oh, okay, go back. I saw 132 divided by 3. Ooh, I think we found it. 132 divided by 4. Cool. Look at that. So I almost kind of wonder. It's interesting. So it's definitely 132. So there you have it. If you have a better way, let me know. Kyle, that's you.
They could be old